right, welcome to section 2.7, Get Real. We're going to be talking about decimals and pinpointing numbers on the real number line. Pause often, try the problems with me, rewatch, rewind. All right, and the question of the day, is there a number between 0.99999 and 1? Pause here, think about it, make a prediction, and we'll come back to it later. So list the following numbers in increasing order from left to right. If you want to pause and try this on your own, go ahead and do so. So what I'm going to do is I'm going to say this is 17.0000. We've got 0.0000. I'm going to use my calculator here. And I'm going to say, okay, what's negative 5 divided by 2? And I get negative 2.5, and after that 5 is a bunch of zeros. And then in my calculator I'm going to type what is the square root of 2? 1.4142. So now increasing order from left to right. So we want our smallest number. Well, our negative number is the smallest, and then 0. And then we've got square root of 2 and 17. So we can reorder these by comparing them all and putting them all into decimals. And we can actually put them right on a number line because numbers are real numbers are numbers that can be ordered. So we can look at this number line here and we can say, all right, 1.7, this is 1.1, 2, 3, 4, 5, 6, 7. And negative 1, 2, 3, 4. And 2.1. So we can actually find these on a number line, and those all have a tens digit there, tenths. But if we want to go a little bit closer, if we want to look at the hundredths digit, we've got 0.71 and 0.76. So now we're looking between 0.7 and 0.8, and we can break that up even more. 71, 0.71, 72, 73, 74, 75, 76. So we can keep getting closer and closer to numbers on a number line. And actually, we can even go so far as to say there will always be another number between them. So we can actually organize numbers. So real numbers is like our big header. Now there are imaginary numbers. We're not going to be talking about them here, but there are imaginary. We're only talking about the real numbers. The numbers we can actually, touch. So there are two types of real numbers. There are the rational and the irrational. Now, rational numbers can be written as a fraction. So integers can be written like 2 over 1. That's a rational number. Also 1/2, 1/3, negative or positive. It can also be decimals if they repeat. So like 0.33333, that's rational. Repeating pattern, 0.121212, that's rational. If it ends, 0.1. It is rational. So what's irrational? Decimals that do not end or do not repeat. So they have to do both. They do not end and they do not repeat. So it's like 1, 2, 3, 4, 5, 7, 2, 3, 1, 4. I mean, I don't know what's going to happen next. That's irrational. You also have numbers like pi and e and square root of 2 we've seen. Those are irrational. So if we just want to look at the decimal expansions here, rational numbers, the decimals end. So the decimals end or they repeat either a number or a pattern. And here they don't end, no end, and no pattern. So when we look at the expansion of a decimal, that's really what we want to do. So find the decimal expansion, using long division for the following numbers. So I'll show you kind of how to do, if you don't remember how to do long division. So 1 divided by 5. 1 divided by 5. So we're dividing 1 by 5. Okay? And 5 can't actually go into 1, so we're going to use a decimal, and we'll just expand it out. So how many times does 5 go not into 1, but 10, 2 times, and there's no remainder. So 1 divided by 5 is actually 0.2. 1/5 is 0.2. What about 11 divided by 4? 11 divided by 4, and that should actually say 4 divided by 11, 4 divided by 11. So 4 divided by 11. So 11 doesn't go into 4, but we can expand it out. So 40. How many times does 11 go into 40? 3 times 33. We get leftover 7. Well, it doesn't go into 7, but it does go into 70. How many times does 11 go into 70? 11 goes into 70 6 times, 66. And we get a 4. Now wait, we've already done 4 before. 11 goes into 4 3 times, 33. And we get back out a 7. Okay, I'm starting to see a pattern. 76. This is going to go on forever. 4 divided by 11 is 0.3636 repeating. 1 divided by 3. Well, that goes in 3 times. Make sure the decimals line up. You get 9. You get a 1 back. Okay, wait, we've already done 10. We're going to have to do it again. 3 times 3, 9. Okay, I'm seeing a pattern here. And you can see that it's going to be 0.33333 repeating. Now, if you were to do 22 divided by 7, 22 divided by 7, 7 does go into 22, so you might get excited. That's 3, 21. And you get 1, bring down the 0, and 1, so 7. You get 3, bring down the 0, you get 30. 7 goes into 30 4 times, so you get 28, 2, 20, so that would be 2, 14, and you get 6, something, it's not repeating yet, 60, and that would be 5, 6, 7, 7, 8, 8. 8 is 56, and we get 4. Let's see here. And so actually, let's take a peek what happens when we do 22 divided by 7, because I'm running out of space. We get 3, 1, 4, 2, 8, 5, 7, 1, 4, and I bet you that 3 is 2, 8. This whole thing repeats 1, 4, 2, 8, 5, 7. 1, 4, 2, 8, 5, 7 over and over and over again. So go ahead and give this a try. Write out the long division 45 divided by 7 to at least 14 places after the decimal. And how can you see that the decimal answer is forever? So give it a shot, and I'll show you my answer in a moment. And so as you keep going, you start to notice a pattern here. So we get that we've done 30 before, and it starts to repeat and starts to repeat. So at certain points you can say, okay, is it going to go on forever? Is there a pattern? What can we decide? So let's look at these. Which numbers are rational and why? So 1.25. I'm actually going to ask you to pause it, try these on your own, and press play when you're ready to see the answer. So 1.25 is rational because the decimal ends. 0.33 is rational because the decimal repeats. 1, 2, 1, 3, 4. So, okay, 1, 2, 1, 3, 4, 1, 2, 8, 1, 9. There's no pattern here, and it's not ending. And this ends, so it is rational. So we're going to pause here, and when we come back, we're actually going to reverse the decimal expansion.